To finish this problem, we need to apply the conditions for static equilibrium. So the sum of the torques about the pivot have to be 0, the sum of the forces in the x have to be 0, and the sum of the forces in the y have to be 0. Let's start with the sum of the torques, and that's going to let us find our tension. So the sum of the torques, since it's not rotating, has to be 0. By sum of the torques, we mean we'll add up everything in our torque column of the table. L times T times cosine 35 degrees minus L over 2 times M times G times cosine 25 degrees plus 0 equals 0. So there's our sum of the torques. There's our equilibrium condition, the first one. We didn't know the length of the post, but we see that we have an L in both terms, so we could divide both sides through by L and they cancel. So then that gives us T times cosine 35 degrees. And then we'll bring our half mg cosine theta to the other side equals plus a half times mg times cosine 25 degrees. So there's our sum of our torques. To get our t, we'll divide both sides by cosine of 35 degrees. So t equals 1/2 mg cosine 25 divided by cosine 35 degrees. We'll plug in G is 9.81, mass is 25 kilograms, and we'll get a tension magnitude of 136 newtons. Then to finish, we have to write our tension as a vector. So our tension equals 136 newtons. As a vector means we put it in it with our vector notation. We'll use polar, so we'll use the magnitude and angle, and we see that the angle of our tension is 30 degrees above the horizontal. So at 30 degrees above x. Or you could say above horizontal, that's fine too. Or you could break it into components and write it in unit vector notation. Okay, there's our tension vector. Next, let's find the bolt force. So to find the bolt force, we're going to go to the x and y components of our forces. We know that because it's not moving, the sum of the forces has to be 0. Let's do the sum of the forces in the x direction first. Sum of the forces in the x direction is mass times acceleration in the x. It's not moving, so ax equals 0. We'll fill in what we have here. T times cosine 30 minus the force of the bolt in the x direction equals 0. So the force of the bolt in the x direction equals t times cosine of 30 degrees. Fill in the t that we just found, 136 newtons, multiply by cosine of 30 degrees. Equals 117 newtons. So there's our x component for the bolt force in the y direction. Next, we'll want to find the y component. So we'll use our sum of the forces in the y direction. Sum of the forces in the y direction equals mass times acceleration in the y equals 0. T times sine 30 minus mg plus the force of the bolt in the y equals 0. Solve for the force of the bolt in the y equals m times g minus t times sine 30. Let's put in the numbers that we know. Mass is the mass of the post, 25 kilograms. G is 9.81. T is the tension that we found when we applied the condition of static equilibrium for the torques. So that was 136 newtons. Multiplying that by sine of 30 degrees. Put all that through the calculator and we get 177 newtons. There's our x and y components of the bolt force. To finish, we just have to write it as a vector. Let's do this one in unit vector notation since we know the components. 117 in the x plus 177 in the y with units of newtons. And there's our bolt force.